there are 45 people going on a tour tram. Each tram bench holds 5 people. Which equation can be used to show how many benches will be filled? So they want to know how many benches will be filled. We know how many people are going and how many a bench holds, right? So, give me your answer that you chose. Pick it on your cards. Go. 3, 2, 1. Okay. All right. I like what I'm seeing. So now let's look at what we did. So, there are 45 people total. We know that. And 5 people per bench. So, a number times 5 is going to equal 45. Did they ask us to solve this problem? No. Which equation or which problem, when you're setting it up, that's all they wanted you to know. Guys, it is a multiplication problem. So is there 45 times 5? Is there 5 groups of 45? No. This one's wrong. B, something times times 5 equals 45. Well, we need to know how many benches and 5 people on each bench. So are we counting groups of 5 till we get to 45? Yes. So we're going to keep that in mind. Now, is there a number and we're dividing it dividing 5 into a number to equal 45 times? No. Are we taking a number and dividing it by 45 to equal 5? No. Are we doing any addition? No. Oh, I was so happy not to see any of that being circled. Yay, yay, yay. It should have been B. Now, here's this one. As I'm walking around, I'm seeing some good / icky poo things. Write 2 related multiplication equations for the equation below. The equation is 42 divided by 6 equals. Well, we know they want to know 2 related multiplication equations. So we know immediately I'm doing 2 times problems, 2 multiplication problems, because also multiplication and division are inverse or opposites of each other, right? So, what do we know? We know there's 6. We know it equals 42. So some number times 6 equals 42. If you drew out, many of you drew out what? Arrays. Arrays. I love it. Did you get an answer that looks similar to this? What did you get? Quickly.
I got
7 times 42. Anybody else get that? Yeah. Yes? 7 times 42. If you do 1, 2, 3, 4, 5, 6, and I put numbers in here, look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You got to equal numbers. 19, 20. You got to go. If you kept going and you add all these dots up and you go evenly until you get to what number? 42. You would end up with 6 groups of 7. So we know that 7 times 6 equals 42, which means what? 6 times 7 equals 42. Yay! Exciting. Charles decorated the shaded parts of the window below. Which fraction of the window is decorated? Can you show me what you got on your cards for number 3, please? In 3, 2, 1. All right, we got lots of the same letters. So let's look. All right, first, it's a fraction. The bottom number is going to tell us how many parts we're cutting this into. Count them. 1, 2, 3. We're putting a 6 on the bottom. How many are actually shaded though? 1, 2, 3. Okay, do we see any 3 over 6 here? No. But what do we know? If we skip counted by 3s and could we get to 6? Count, skip count. 3, 6. Uh-oh. So these are actually what we call equivalent fractions. You haven't learned it yet. Is that okay?
Yes.
Try your
best.
This actually is 3 divided by 3 equals 1, and 6 divided by 3 equals 2. It is 1/2. Look, could you look at that too and see that half of those boxes are filled?
Yeah.
So it should be B, 1/2. A lot of us chose 3 because you saw 3 white boxes and 3 filled boxes, didn't you?
Yes.
I could tell. I saw the way you guys were adding them up. All right. Number 4. Which of the following is a quadrilateral with 4 right angles? Well, a right angle, guys, equals 90 degrees. Have we done quadrilaterals yet?
No. Yes.
A little bit. we're going to look. Quadrilaterals, how many sides? Show me on your fingers quickly. Awesome, 4. So we know that's 4 sides. And they want right angles. So your angle has to look like that. 90 degrees, right? Up, up. Do these have 4 sides? 1, 2, 3, 4. Yes. Are they right angles? No. How many sides does this have? Whisper count. 1, 2, 3, 4. Is that 4?
No.
That one gets marked off right away. What about these?
No.
1, 2, 3. Not 4. What about this?
Yes.
4. Do they have a right angle?
Yes.
Are there 4 of them?
Yes.
Brilliant. We definitely have to mark that, but we have to check them all. Do we have 4 sides?
Yes.
Do we have right angles?
No.
Your answer should have been D. The bar graph below shows a favorite ice cream of several students. How many students preferred chocolate to strawberry? Well, here's what our chart's saying. The number of students are right here. These are your types of ice cream. Show me your answers, please. In 3, 2, 1. All right. So we're comparing how many liked chocolate to strawberry. Well, I'm going to go up. Do I need to know about vanilla?
No.
Cards down. No, we don't need to know about vanilla, but we need to know chocolate. So I'm going to go chocolate. I'm going to go up to the number 5. I'm going to put it right there. Strawberry, I'm going to go all the way up to my number 4. If I had 5 who like chocolate, but only 4 who like strawberry, I've got to take away those. They want to know how many preferred chocolate to strawberry. Am I going to solve like this?
No.
No, this is standard algorithm. Ooh. So, we're going to do it in place value blocks. So we're going to count out 1, 2, 3, 4, 5. And how many am I going to mark out?
4.
1, 2, 3, 4. How many do I have left?
1.
If you got E, pat yourself on the back. Great job, folks. At this time, let's see which table can please have all their accolades put up. Their cards and rulers in a nice pile.